Hi everyone and welcome back. I took a closer look at the cleaning performance of the Ecovacs X12. I already tested the Ecovacs X9 some time ago and, especially for a combo device, it performed really well in my carpet tests. It's still featured in 2 of my 3 top 7 rankings. So naturally, I was hoping to see some improvements with the X12. Maybe also when it comes to hard floor cleaning, since that was more of an average performer on the X9. Let's start by looking at my carpet tests. As always, using 3 different carpet types and my certified test dust. And unfortunately, we'll see that the X12 turned out to be a major step backward. We're starting with the red carpet, which has a very thick pile of around 2 centimeters in length. Using the maximum suction setting and the highest overlap in the cleaning pattern, the Ecovacs X12 managed to remove only 16% of the slightly embedded test dust after 14 cleaning passes. That's just 1.6 grams out of 10 grams. That's obviously nowhere near enough to make it into my top 7 for this carpet. You can also see the X9's result shown below. It performed more than twice as well here, but still didn't make it into the top 7 either. Things look a bit better on the dark blue carpet, which has a very soft pile of around 2 centimeters in length. Here, the Ecovacs X12 achieved 69% test dust removal after 14 passes using the same settings as on the red carpet, so 6.9 grams out of 10 grams were removed. That result is actually enough to make it into my top 7 for this carpet, and the X12 kicks the DJI Romo out of this list. Compared to the X9 though, it's still a clear step backward, as the X9 performed significantly better with an additional 16 percentage points reaching 85%. Last but not least, we have this short pile carpet. For this test, 5 grams of test dust were applied and the robot was allowed to make only 7 passes over the carpet. Here, the Ecovacs X12 achieved a result of 50%, meaning it removed 2.5 grams out of the 5 grams in total. That result is obviously not enough to make it into my top 7 ranking for this carpet. And compared to the Ecovacs X9, the performance is clearly worse. The X9 reached 82%, which means it performed 32 percentage points better. Before we get to the possible reasons behind this decline in performance, let's take a quick look at my hard floor test. For this test, I also use certified test dust that simulates typical household dust. A total of 0.45 grams was distributed across my laminate floor. The laminate has a lightly textured surface and also includes small gaps between the individual panels. The robots are then allowed to clean the area using maximum suction power and the highest possible overlap, making a total of 8 passes. After that, I check the result using a microfiber cloth. And as we can see, the Ecovacs X12 doesn't perform particularly well here. Both the surface and, as expected, the gaps remain noticeably dusty. Good cordless stick vacuums can pick this up in 2 to 4 passes, and the Dyson 360 VisNav, being a dedicated vacuum robot, gets both the surface and the gaps completely clean after 4 to 8 passes. Of course, I also took a look at the performance with the mopping function enabled. That means the robot first completed the same 8 vacuum passes and then was allowed to mop the area twice. For the mopping settings, I usually use the medium water level, as that tends to be the most suitable option for my laminate flooring. As expected, the surface ended up clean, but the gap still remained dirty. That matches the typical cleaning outcome I see with the vast majority of combo robots in my tests. So far, only the iRobot Roomba Max 705 combo and the Roomba 205 combo have managed to clean both the surface and the gaps completely in my tests. These models can use a Y pattern while mopping, which provides the decisive advantage here. You can find the corresponding tests on my channel. Just like I did with the Narwhal Flow 2, I also tested the mopping performance using a colored pencil. It's water-based and can be removed fairly easily with a bit of pressure. And yes, just like with the Narwhal Flow 2, edge cleaning is really not very good here. Even the coffee stains that were added as an extra test, somewhat unintentionally, remained along the edges. There were also visible coffee stains across the main floor area, but cleaning those was absolutely no issue. You can clearly see that the colored pencil marks are removed without any problem, especially the long horizontal line at the bottom that extends from the center area all the way to the edge. In the open area, it's cleaned very effectively, but near the edges, hardly at all. All the other dirt across the main area is also removed very well after just 1 or 2 cleaning passes. That was already the case with the Narwhal Flow 2 as well. except when it comes to dirt inside the floor gaps. The Ecovacs X12 also struggles to clean those gaps properly. But that's not really surprising, since we already saw in the dust test that even lighter test dust contamination wasn't cleaned particularly well there. And in my Narwhal Flow 2 video, we already saw that robots using mop pads perform significantly better along the edges in my setup. One example was the older Dream L10's Ultra, which, thanks to its cleaning pattern and sweeping motion, gets much closer to the edges and delivered noticeably better cleaning performance at the edges. There are now also mop pad robots that, at least on paper, apply more pressure to the floor and therefore achieve better results. One example I tested is the Dream L60 Ultra, which performed also significantly better regarding edge cleaning. I'll cover the reasons behind all of this in a separate video. We're now looking at a second cleaning pass, but nothing changed along the edges. As I said, the cleaning performance across the open floor area was actually very good. Next, we'll take a quick look at some comparison photos before moving on to the analysis of why the cleaning performance dropped so much compared to the X9, and we talk a bit about the fast charging feature. On the left side of the image, you can see the marks in its original condition, and on the right after 4 cleaning runs or 2 edge cleaning runs. As already mentioned and expected, some paint remains in the grout. Otherwise, the surface has been cleaned very well. In the edge area, however, the result is rather weak. Compared with the pen, which is about 14 centimeters long, you can clearly see that the edge areas are not being cleaned sufficiently. Of course, I also took a closer look at the spray function for softening stains. In principle, this is a feature you already know from the iRobot Brava Jet models, which spray water onto the floor in front of the robot through a nozzle. On the Ecovacs X12, there is an automatic mode to detect stains and use the spray function, but unfortunately it did not trigger in my tests. I applied different types of stains in different sizes and colors to create enough contrast on the floor, but the robot still did not start the function automatically. You can, however, start it manually. In that case, you select an area that should be cleaned in spray mode. The robot first wets this area with water so the stains can soak in, and then, during the subsequent 2-pass cleaning process, it picks up the water and the dirt. I am not completely sure, but I believe that in this mode the mop roller is not additionally wetted with water again. We will also see that in the cleaning results, because these purple stains are not picked up quite as well compared with the ones shown earlier. In my test, a small amount of residue remains. However, the question is also whether the different pen color played a role here, so that should perhaps be treated with a question mark. What also becomes clear is that this mode has a downside. By softening the dirt, it can then be redistributed a bit by the robot's wheels. You can see that, for example, with the green stains, which are carried quite a distance across the surface by the robot. They do get cleaned up later as well, but the problem remains that such dirt can stick to the wheels. With the Dyson Spot and Scrub and its low docking signal frequency, for example, I had the problem with soy sauce that this kind of buildup actually caused docking issues too. Apart from the hygiene aspect, that is obviously not a very pleasant thing either. So the question here is how the robot actually handles such dirt in automatic mode. From what I have seen so far, it simply depends on how well the robot detects a stain, and that will never work 100% of the time. Especially with robots built like these hybrid devices, there is always the risk that something ends up in the wheels and is then carried into other rooms, which also makes the robot dirty overall, and is just a bit unpleasant in general. Yes, that is it for mopping. Now we are actually moving on to the root cause analysis of why the X12 vacuuming performance is like it is. Let's move on to analyzing the causes behind the observed cleaning performance results. First, a quick clarification. I no longer perform measurements of airflow or static pressure. What matters here are the real-world cleaning results from my standardized test procedure. All technical specifications referenced are provided by Ecovacs, and my assessment is based on the results and experience with comparable systems. Starting with the official specs, the Ecovacs X12 is rated at 22 liters per second of airflow, approximately 46.6 CFM, and 22,000 Pascal. The X11 that I also put in here and I'm going to test soon is specified at 38 CFM and 19,500 Pascal. The X9 comes in at 34.5 CFM and 16,600 Pascal. In this context, there is also an interesting detail in the official specifications. For the X12, Ecovacs labels the 22,000 Pascal figure as claimed in brackets, while this note is not present for the X11 or the X9. A key difference with the X12 is the redesigned main brush system and airflow design. The brush is mounted on one side only, while the opposite side features a gap with the suction channel next to it. This design is intended to enable an anti-tangle function, where hair is actively pulled off the brush and into the suction path by the airflow. However, based on experience and measurements with similar designs such as Dream's system, this type of construction often results in weaker real-world cleaning performance. This aligns with the results I've measured so far. One possible explanation is that the higher nominal airflow and suction power of the X12 are largely required to compensate for this brush and airflow design. As a result, a significant portion of that performance may be effectively consumed by the system itself, leaving less usable airflow and pressure at the floor compared to previous models. Another factor could be the one-sided brush mounting. This may reduce the brush's ability to properly engage with and lift carpet fibers. Additionally, the brush motor may be limited in torque to avoid excessive mechanical stress on the asymmetric mounting, or is not allowed to use more torque due to the design. To be honest, that explanation alone was not sufficient enough to me, since the performance drop compared to the X9 is simply too significant. So I took a closer look at the spec sheets, and beyond the already mentioned claimed label on the X12's suction rating, 3 additional points stand out. First, battery energy. The X12 is rated at 51.84 watt-hour, while both the X9 and X11 are listed at 83.52 watt-hour with rated 3600 mAh and rated 5800 mAh respectively. All 3 batteries are based on a nominal voltage of 14.4 volts. This is important because milliampere hours alone is not a meaningful metric and has to be always connected with the given nominal voltage, resulting in the available watt-hour. Good examples are the Dyson VisNav and the Samsung PowerBot VR9350, both with batteries around 4,500 mAh but at 21.6 volts, resulting in around 94 watt-hour. This is why direct milliampere hours comparisons across different voltage platforms can be misleading, but still promoted by various reviewers. Another interesting detail: the X9 operates directly at 14.4 volts, matching the battery voltage. The X11 and X12, however, run at a working voltage of 20 volts and 17.8 volts respectively. This strongly suggests the use of boost converters, which introduce conversion losses but can offer design advantages. For cleaning performance, however, this is a secondary factor. More critical is the total power budget. All 3 devices are rated at 110 watts. That means every subsystem has to operate within that limit. And this is where things get interesting for the X12. Compared to the X9, it includes additional power consumers such as the spray pump, likely a more powerful motor for the larger and heavier mop roller, and a more complex sensor setup, including an advanced wall sensor with both horizontal and vertical light sectioning. And probably more compute power compared to its predecessors for all the AI stuff. All of these draw from the same fixed power budget. So to figure out what is going on in more detail, I measured power consumption in vacuum-only mode. I had the X12 and X9 clean the exact same simple area without obstacles, and tracked how long it took each device to consume 20% of its battery. I then extrapolated that to estimate actual power draw. The results are quite revealing. The X9 draws about 96.7 watts, with a theoretical runtime of around 3,100 seconds. The X12, on the other hand, draws only about 65.3 watts, with a runtime of roughly 2,958 seconds. This is a substantial difference in power draw in vacuum-only mode. So the key question is, how can a robot that claims significantly higher suction performance on paper consume around 30 watts less power in vacuum mode? There are 2 plausible explanations. Either the system uses significantly more efficient components, especially the vacuum motor, or it is effectively power limited by design or the used hardware. To investigate further, I also examined the internal design of the X12. The suction motor has been relocated, but airflow routing and insulation are largely comparable. One notable addition is a large cooling element positioned close to or in the airflow path, which is not present in the X9 and, judging from exploding view, the X11. It is likely related to the fast charging system, but that requires further analysis since I did not tool it fully apart in my opening video, and right now there are no exploded drawing available for the X12. More importantly, the motor itself has changed. The X12 uses a C5 variant of a 30BL motor from Kelly Motors, while the X9 and X11 use C7 variants. There are no public data sheets for these available. However, based on typical naming conventions, the higher numbered version is usually the more powerful one. My test results strongly support the conclusion that the C5 motor in the X12 is simply less powerful. While it is theoretically possible that this is a more efficient design delivering comparable performance at lower power, the measured cleaning results and power drawings make that scenario unlikely, or the new cleaning system design has much more negative impact than I thought. As mentioned earlier, I did not perform direct measurements of airflow or static pressure. What I am presenting here is based on my test results, combined with an assessment of the available data. Ecovacs also does not provide any verifiable evidence for its advertised suction figures. The values are simply stated on their website, without detailed test conditions, without footnotes, and not even with a note indicating that they are based on internal measurements. What conclusions you draw from that is ultimately up to you. As for me, my position is clear. The X12 uses a less powerful vacuum motor, and in combination with the redesigned airflow path and brush system, this results in the noticeably weaker cleaning performance. In that context, the claimed label on the X12's specification becomes particularly noteworthy and should not be overlooked. Finally, let's take a closer look at the charging behavior of the X12. Ecovacs advertises a fast charging feature here, which is particularly relevant for the mop roller cleaning intervals. Specifically, they claim around 13% charge within 3 minutes. For comparison, the X11 was rated at about 6% within the same time frame. At first glance, this might suggest that the X12 is roughly twice as fast. However, if you convert these figures into watt-hours, the picture changes a bit. The X12 gains about 6.74 watt-hours during this interval, while the X11 reaches about 5 watt-hours. That's still roughly a 34.5% increase, but far from a doubling. Looking at the official charging times, the X9 and X11 perform very similarly overall, despite the X11's fast charging feature. This is likely because the X11 charges with higher current at the start, which generates more heat. As a result, the charging curve tapers off more quickly, offsetting the initial advantage. With the X12, it's also noticeable that the total charging time is relatively slow in relation to its battery capacity. I assume it is for the same heat-related reason, using high current at the start that also requires this extra cooling element for the battery and a flat charging curve later on. If you scale the charging performance of the X12 to the 83.52 watt-hour battery, assuming the same charging curve, it would theoretically recharge it in about 4 hours. Things get more interesting in real-world testing. I had both the X12 and the X9 clean roughly 52 square meters using a double-pass cleaning mode, resulting in 114 square meters cleaned. The X12 finished about 10 minutes faster, with an overall time of 144 minutes compared to the 154 minutes of the X9. However, the charging behavior tells a more nuanced story. The X12 returned to the dock twice, recharging about 22.3 watt-hours first and then another 9.3 watt-hours, taking roughly 50 minutes in total. The X9, by contrast, only needed a single recharge, taking in about 29 watt-hours in about 57 minutes. Overall, the total cleaning time for both devices in this area is quite similar. The X12 gains its advantage primarily through shorter but more frequent charging intervals. At the same time, the trade-off becomes clear. Despite lower energy consumption, the smaller battery means the X12 has to recharge more often. If you scale this up to larger areas, say around 200 square meters, the X12's time advantage will likely become more pronounced, but at the cost of additional charging stops. It's also worth noting that the X12 stopped its first charging session at around 68%. This is likely the point where the charging curve begins to flatten significantly, meaning further charging would not provide a meaningful time benefit. Within roughly 30 minutes, it had already recovered about 22.3 watt-hours, and beyond that, the gains per minute would likely drop off. From a long-term perspective, the impact on battery lifespan is an open question. Frequent charging cycles combined with higher thermal stress could potentially be disadvantageous compared to devices like the X9 or X11 with larger batteries. However, this is more of an assumption than a definitive conclusion due to the lack of in-depth knowledge regarding battery tech on my side. What can be said with confidence is that the smaller battery capacity of the X12 will have downsides in certain scenarios. There will be floor areas that an X9 can clean without interruption, while the X12 will inevitably require one or more charging breaks. So, let's wrap this up. In my opinion, the X12 is a disappointment. It's a step backwards compared to the X9, and I'm curious to see how the X11 performs in my upcoming tests. The biggest issue is that we simply didn't see any meaningful improvements in cleaning performance, and worse, a big downgrade regarding carpet cleaning. Edge cleaning while mopping was a complete disaster. I'll cover that in much more detail in a separate video, because the X12 certainly isn't the only robot that failed in this area. That's it from me. Thanks for watching, and thank you for all your support. I'll see you in the next one. Bye.